Namaste dear children, I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Class 6 Maths Chapter 5 Prime Time Part 4. Prime factorization. Checking if two numbers are co-prime. We have to check whether two numbers are co-prime. Teacher asked, are 56 and 63 co-prime? Then Anshu and Guna said, if they have a common factor other than 1, then they are not co-prime. They said, if these numbers have a common factor other than 1, then they are not co-prime. Anshu, I can write 56 is equal to 14 into 4 and 63 is equal to 21 into 3. So, 14 and 4 are factors of 56. Further, 21 and 3 are factors of 63. So, there are no common factors. The numbers are co-prime. So, what Anshu did? She wrote 56 is equal to 14 into 4 and 63 is equal to 21 into 3. So 14 and 4 are factors of 56, 21 and 3 are factors of 63. So there are no common factors. So she said these numbers are co-prime. Then, is it correct? Let us see. Guna said, hold on, I can also write 56 is equal to 7 into 8 and 63 is equal to 9 into 7. So Guna, she wrote in another way. 56 is equal to 7 into 8 and 63 is equal to 9 into 7. So, we see that 7 is a factor of both numbers, so they are not co-prime. So, 7 is a common factor. So, these numbers are not co-prime. Clearly, Guna is right as 7 is a common factor. But where did Anshu go wrong? Writing 56 is equal to 14 into 4 tells us that 14 and 4 are both factors of 56. But it does not tell all the factors of 56. The same holds for the factors of 63. So, writing 56 equal to 14 into 4 tells us that 14 and 4 are factors of 56, but it does not tell all the factors of 56. Try another example, 80 and 63. There are many ways to factorize both numbers. So, we have another example, 80 and 63. There are different ways to factorize both numbers. See, 80 is equal to 40 into 2. 40 into 2 is 80. Also, 20 into 4 is 80. 10 into 8 is 80. 16 into 5 is 80. So, 80 is equal to 40 into 2 is equal to 20 into 4 is equal to 10 into 8 is equal to 16 into 5. Similarly, 63 is equal to 9 into 7. 9 into 7 is 63. It is equal to 3 into 21. 3 into 21 is also 63. We have written question marks to say that there may be more ways to factorize these numbers. There will be more ways. But if we take any of the given factorizations, for example, 80 equal to 16 into 5, 63 is equal to 9 into 7, then there are no common factors. So, if you factorize 80 as 16 into 5 and 63 as 9 into 7, then there are no common factors. Can we conclude that 80 and 63 are co-prime? As Anshu's mistake above shows, we cannot conclude that, as there may be other ways to factorize the numbers. We cannot conclude that these numbers are co-prime because there will be other ways to factorize a number. What this means is that we need a more systematic approach to check if two numbers are co-prime. Prime factorization. Take a number such as 56. It is composite. As we saw that it can be written as 56 is equal to 4 into 14. So both 4 and 14 are factors of 56. Now take one of these, say 14. 56 is equal to 4 into 14. Now take 14. It is also composite and can be written as 14 is equal to 2 into 7. Therefore, 56 is equal to 4 into 2 into 7. Now 4 is composite and can be written as 4 equal to 2 into 2. Therefore, 56 is equal to 2 into 2 into 2 into 7. All the factors appearing here, 2 and 7 are prime numbers. So, we cannot divide them further. We can stop here. In conclusion, we have written 56 as a product of prime numbers. This is called prime factorization. See, 56 is equal to 2 into 2 into 2 into 7. Here, 2 and 7 are prime numbers. So, we wrote 56 as a product of prime numbers. This is called prime factorization of 56. The individual factors are called prime factors. For example, the prime factors of 56 are 2 and 7. Every number greater than 1 has a prime factorization. So, every number greater than 1, it has a prime factorization. The idea is the same. Keep breaking the composite numbers into factors till only primes are left. So, this is how we can do prime factorization. Keep breaking the composite numbers into factors till only primes are left. The number 1 does not have any prime factorization. It is not divisible by any prime number. So, this is important. Which number has no prime factorization? Number 1 does not have any prime factorization. It is not divisible by any prime number. What is the prime factorization of a prime number like 7? It is just 7. We cannot break it down any further. So, prime factorization of a prime number is the number itself. Let us see a few more examples. By going through different ways of breaking down the number, we wrote 63 as 3 into 3 into 7 and as 3 into 7 into 3. Are they different? Not really. The same prime numbers 3 and 7 occur in both cases. Further, 3 appears 2 times in both and 7 appears once. So, 3 into 3 into 7, 63 is equal to 3 into 3 into 7 is same as 63 is equal to 3 into 7 into 3. Because the same prime numbers 3 and 7 occur in both cases. 3 appears how many times? 2 times in both and 7 appears only once. Here you see 4 different ways to get prime factorization of 36. Observe that in all 4 cases we get 2 2's and 2 3's. Let us see. See, first case 36 is equal to 2 into 18. So, 18 is a composite number. So, we can break further. 18 is equal to 2 into 9. So, this becomes 2 into 2 into 9. Then, again, 9 is a composite number. So, we can change 9 as 3 into 3. So, this whole becomes 2 into 2 into 3 into 3. Then, we will see the next case. 36 is equal to 3 into 12. 12 is a composite number. So, 12 can be changed to 3 into 4. So, here it becomes 3 into 3 into 4. Then, again, 4 is a composite number. So, we can write 4 as 2 into 2. So 3 into 3 into 2 into 2. The next one. See here all factors are prime factors. So we can stop here. You just rewrite like this 2 into 2 into 3 into 3 just for convenience. Next 36 is equal to 4 into 9. Here 4 and 9 both are composite numbers. So we can rewrite 4 as 2 into 2 into 9. Then 9 can be written as 3 into 3. So 2 into 2 into 3 into 3. Next case 36 is equal to, we can write as 6 into 6. So 6, rewrite 6 as 2 into 3. So 2 into 3 into 6. So again this 6 is a composite number. So we can rewrite as 6 equal to 2 into 3. So here it becomes 2 into 3 into 2 into 3. Here 2 and 3 both prime factors. So we can stop here. We can just rewrite as 2 into 3 into 2 into 3. For convenience we can write like this 2 into 2 into 3 into 3. Multiply back to see that you get 36 in all 4 cases. Yes, 2 into 2 into 3 into 3 is 36. 2 into 2 into 3 into 3 is 36. So in all cases it is 36. For any number, it is a remarkable fact that there is only one prime factorization. So prime factorization, there is only one prime factorization. So this is very important. So there is only one prime factorization, except that the prime factors may come in different orders. Sometimes it is 2 into 2 into 3 into 3. Sometimes it will be 2 into 3 into 2 into 3. Okay. Order will change. As we explained below, the order is not important. However, as we saw in these examples, there are many ways to arrive at the prime factorization. So there are different ways to arrive at the prime factorization. Using this diagram, can you explain why 30 is equal to 2 into 3 into 5? No matter which way you multiply 2, 3 and 5. So when multiplying numbers, we can do so in any order. Then result is a C. That is why when 2 2's and 2 3's are multiplied in any order, we get 36. So while doing multiplication, we can do in any order. Then result will be same. In a later class, we shall study this under the names of commutativity and associativity of multiplication. Thus, the order does not matter. Usually, we write the prime numbers in increasing order for convenience. For example, 225 is equal to 3 into 3 into 5 into 5. Or 30 is equal to 2 into 3 into 5. So, in the increasing order, we will write usually for convenience. Prime factorization of a product of two numbers. When we find the prime factorization of a number, we first write it as a product of two factors. When we find the prime factorization of a number, first we will write it as a product of two factors. For example, 72 is equal to 12 into 6. We express 72 as a product of two factors. Then we find the prime factorization of each of the factors. We have to find the prime factorization of 12 and prime factorization of 6. In the above example, 12 is 2 into 2 into 3 and 6 is 2 into 3. Now, can you say what the prime factorization of 72 is? The prime factorization of the original number is obtained by putting these together. 72 is equal to Instead of 12, we can write 2 into 2 into 3. Then instead of 6, we can write 2 into 3. So 72 is equal to 2 into 2 into 3 into 2 into 3. We can also write this as 2 into 2 into 2 into 3 into 3. In the increasing order, we can write. Multiply and check that you get 72 back. Observe how many times each prime factor occurs in the factorization of 72. Compare it with how many times it occurs in the factorizations of 12 and 6 put together. Find the prime factorization of the following numbers. First we will see 64. 64 is equal to 2 into 32. Then 32 we can rewrite as 2 into 16. So 2 into 2 into 16. Again 16 is a composite number. So we can break like this. 2 into 8. So 64 is equal to 2 into 2 into 2 into 8. Again we can rewrite 8 as 2 into 4. Then 4 can be written as 2 into 2. So this is a prime factorization of 64. 2 into 2 into 2 into 2 into 2 into 2. Next one, 104. We can write 104 as 2 into 52. 52 is a composite number. So we can rewrite 52 as 2 into 26. So 52 is equal to 2 into 26. Then what about 26? It is a composite number. So we can rewrite 26 as 2 into 13. See, now all factors are prime factors. We can stop here. So 2 into 2 into 2 into 13. This is the prime factorization of 104. Next number 105. We can write 105 as 3 into 35. Here 35 is a composite number. We can rewrite as 5 into 7. So 105 is equal to 3 into 5 into 7. 3, 5, 7 are all prime factors. Next one, 243. We can write 243 as 3 into 81. So 81 is a composite number. We can rewrite as 3 into 27. Again 27 is a composite number. We can rewrite as 3 into 9. Then again 9 is a composite number. We can rewrite as 3 into 3. So prime factorization of 243 is 3 into 3 into 3 into 3 into 3. Next number 320. 320 can be written as 2 into 160. 160 is a composite number. We can rewrite as 2 into 80. Again, 80 is a composite number. We can rewrite as 2 into 40. So again, 40 is a composite number. So we can rewrite as 2 into 20. Again, 20 is a composite number. So we can rewrite as 2 into 10. Again, 10 is a composite number. So we can rewrite as 2 into 5. Now, all factors are prime. See 2 into 2 into 2 into 2 into 2 into 2 into 5. Next number 141. We can rewrite as 3 into 47. So, these two are prime numbers. So, the prime factorization of 141 is 3 into 47. Next number 1728. We can write as 2 into 864. So 864 we can rewrite as 2 into 432. Then 432 is a composite number. We can rewrite as 2 into 216. So 216 is a composite number. We can rewrite as 2 into 108. 108 can be written as 2 into 54. Again, 54 can be written as 2 into 27. Then 27 can be written as 3 into 9. 9 can be written as 3 into 3. So this is the prime factorization of 1728. Next number is 729. This can be written as 3 into 243. 243 is a composite number. We can rewrite as 3 into 81. Again, 81 can be written as 3 into 27. 27 can be written as 3 into 9. Then 9 can be written as 3 into 3. This is the prime factorization of 729. So next number is 1024. This can be written as 2 into 512. 512 is a composite number. So we can write this as 2 into 256. Again, 256 can be written as 2 into 128. Then 128 can be written as 2 into 64. Then again 64 can be written as 2 into 32. 32 can be written as 2 into 16. Then 16 can be written as 2 into 8. Then 8 can be written as 2 into 4. 4 can be written as 2 into 2. So this is the prime factorization of 1024. Next number is 1331. This can be written as 11 into 121. Again, 121 can be written as 11 into 11. So this is the prime factorization of 1331. Next number is 1000. 1000. This can be written as 2 into 500. So 500 can be again written as 2 into 250. So 250 can be written as 2 into 125. 125 can be written as 5 into 25. Then again 25 can be written as 5 into 5. So this is the prime factorization of 1000. The prime factorization of a number has 1, 2, 2 threes and 1 11. What is the number? So the prime factorization of the number has 1, 2, 2 threes and 1 11. So the number will be the product of these prime factors. So 2 into 3 into 3 into 11, that is 198. Next one, find 3 prime numbers, all less than 30, whose product is 1955. So 1955 we can prime factorize as 1955 is equal to 5 into 391. Then 391 we can rewrite as 17 into 23. So the prime factorization of 1955 is 5 into 17 into 23. Here 5, 17 and 23 are prime numbers. So the 3 prime numbers are 5, 17 and 23. Find the prime factorization of these numbers without multiplying first. First one is 56 into 25. First we have to find the prime factorization of 56. 56 is equal to 2 into 2 into 2 into 7. Then prime factorization of 25, 5 into 5. Therefore, 56 into 25 is equal to 2 into 2 into 2 into 7 into 5 into 5. Next one, 108 into 75. So, prime factorization of 108 is 2 into 2 into 3 into 3 into 3. Then we have to find the prime factorization of 75. Prime factorization of 75 is equal to 3 into 5 into 5. Therefore, 108 into 75 is equal to product of prime factorization of 108 and prime factorization of 75. That is 2 into 2 into 3 into 3 into 3 into 3 into 5 into 5. Next one, 1000 into 81. So first we have to find prime factorization of 1000. Prime factorization of 1000 is 2 into 2 into 2 into 5 into 5 into 5. Then we have to find prime factorization of 81. Prime factorization of 81 is equal to 3 into 3 into 3 into 3. Therefore, 1000 into 81 is equal to product of prime factorization of 1000 and prime factorization of 81. So, you will get the answer like this. What is the smallest number whose prime factorization has 3 different prime numbers? To find the smallest number with the 3 different prime factors, we need to multiply the 3 smallest prime numbers together. Which are the 3 smallest prime numbers? 2, 3 and 5. So, the smallest number with the 3 different prime factors is 2 into 3 into 5 is equal to 30. Next one. What is the smallest number whose prime factorization has 4 different prime numbers? To find the smallest number with the 4 different prime factors, we simply multiply the first 4 prime numbers together. So, the first 4 prime numbers are 2, 3, 5 and 7. So, their product is 210. So, 210 is the smallest number with the 4 different prime factors. Prime factorization is of fundamental importance in the study of numbers. Let us discuss 2 ways in which it can be useful. So, prime factorization can be very useful in the study of numbers. First one, using prime factorization to check if 2 numbers are co-prime. So, using prime factorization, we can check whether 2 numbers are co-prime or not. Let us again take the numbers 56 and 63. How can we check if they are co-prime? If they are co-prime, then there is only one common factor 1, no other common factors. So, we can use the prime factorization of both numbers. So, 56 is equal to 2 into 2 into 2 into 7. Then 63 is equal to 3 into 3 into 7. Now, we see that 7 is a prime factor of 56 as well as 63. Therefore, 56 and 63 are not co-prime. So, using prime factorization, we can check if 2 numbers are co-prime. See, 56, when we prime factorize, we will get 2 into 2 into 2 into 7. 63, when we prime factorize, we will get 3 into 3 into 7. In both cases, 7 is a factor. So, 7 is a common factor of both 56 and 63. Therefore, 56 and 63 are not co-prime. Then what about 80 and 63? Their prime factorization are as follows. 80 equal to 2 into 2 into 2 into 2 into 5. 63 is equal to 3 into 3 into 7. There are no common prime factors. Can we conclude that they are co-prime? Yes, we can conclude that 80 and 63 are co-prime. Therefore, we can say that if there are no common prime factors, then the 2 numbers are co-prime. So, how do you check if 2 numbers are co-prime using prime factorization? If there are no common prime factors, then the 2 numbers are co-prime. Let us see some examples. Consider 40 and 231. Their prime factorizations are as follows. So, we have to check whether 40 and 231 are co-prime. So, we have to first prime factorize 40 and 231. 40 is equal to 2 into 2 into 2 into 5. 231 is equal to 3 into 7 into 11. So, we see that there are no common primes that divide both 40 and 231. Indeed, the prime factors of 40 are 2 and 5, while the prime factors of 231 are 3, 7 and 11. Therefore, 40 and 231 are co-prime because there are no common factors for 40 and 231. There are no common prime factors for 40 and 231. Next example, consider 242 and 195. Their prime factorizations are as follows. 242 is equal to 2 into 11 into 11. 195 is equal to 3 into 5 into 13. So, the prime factors of 242 are 2 and 11. Prime factors of 195 are 3, 5 and 13. There are no common prime factors. Therefore, 242 and 195 are co-prime. So to check whether two numbers are co-prime, we have to prime factorize the numbers. Then if there are no common prime factors, then the numbers are co-prime. Next, we will see another use of prime factorization. Using prime factorization to check if one number is divisible by another. We say that if one number is divisible by another, the prime factorization of the second number is included in the prime factorization of the first number. So, if one number is divisible by another number, then the prime factorization of the second number is included in the prime factorization of the first number. We say that 48 is divisible by 12 because when we divide 48 by 12, what will be the remainder? The remainder is 0. So 48 is divisible by 12. How can we check if one number is divisible by another without carrying long division? For example, is 168 divisible by 12? So first find the prime factorization of both. 168 is equal to 2 into 2 into 2 into 3 into 7. And 12 is equal to 2 into 2 into 3. Since we can multiply in any order, now it is clear that 168 is equal to 2 into 2 into 3 into 2 into 7. That is 12 into 14. Therefore, 168 is divisible by 12. So, to check if 168 is divisible by 12, we have to prime factorize both numbers. Then, if the prime factorization of the second number is included in the prime factorization of the first number, then the first number is divisible by second number. So here the prime factorization of the second number 12 is 2 into 2 into 3. This is included in the first number. Prime factorization of first number. See 2 into 2 into 3. So 168 is divisible by 12. See, we can write the factors in any order. So for convenience, we write it as 2 into 2 into 3 first and then 2 into 7 like this 2 into 7, that is 2 into 2 into 3 is 12, then into 7 into 2 is 14. Okay, so 168 is divisible by 12. Then we will see some examples. Is 75 divisible by 21? So we have to find the prime factorization of both. 75 is equal to 3 into 5 into 5. Then what is 21? 21 is equal to 3 into 7. Is 75 divisible by 21? No. Why? If one number is divisible by another number, then the prime factorization of the second number must be included in the prime factorization of first number. See here, prime factorization of second number, that is 21, is 3 into 7. But 3 into 7 is not included in the prime factorization of 75. Only 3 is there. 7 is not there. So, 75 is not divisible by 21. As we saw in the discussion above, if 75 was a multiple of 21, then all prime factors of 21 would also be prime factors of 75. However, 7 is a prime factor of 21 but not a prime factor of 75. Therefore, 75 is not divisible by 21. Next example, is 42 divisible by 12? Find the prime factorization of both. 42 is equal to 2 into 3 into 7. Then 12 is equal to 2 into 2 into 3. Is 42 divisible by 12? No. Why? See here, all prime factors of 12 are also prime factors of 42. See, 2 and 3 are prime factors of 12. 2 and 3 are present in 42 also. But the prime factorization of 12 is not included in the prime factorization of 42. This is because 2 occurs twice in the prime factorization of 12, but only once in the prime factorization of 42. This means that 42 is not divisible by 12. Here, the prime factorization of 12 is not included in the prime factorization of 42. So, 42 is not divisible by 12. In the prime factorization of 12, there are 2 2's and 1 3. But in the prime factorization of 42, there is only 1 2. So, 42 is not divisible by 12. We can say that if one number is divisible by another, then the prime factorization of the second number is included in the prime factorization of the first number. Figure it out. Are the following pairs of numbers co-prime? Guess first and then use prime factorization to verify your answer. First one, 30 and 45. To determine if 30 and 45 are co-prime, we need to find their prime factorizations. So first we have to find prime factorization of 30. 30 is equal to 2 into 3 into 5. Then prime factorization of 45. 45 is equal to 3 into 3 into 5. As we can see, both numbers share the prime factors 3 and 5. Therefore, 30 and 45 are not co-prime. Next one, 57 and 85. Prime factorization of 57. How do you find? 57 divided by 3 is equal to 19. Then 19 divided by 19 is equal to 1. So 57 is equal to 3 into 19. The next one, prime factorization of 85. 85 divided by 5 is 17. Then 70 divided by 17 is equal to 1. So 85 is equal to 5 into 17. As we can see, the prime factors of 57 and 85 have no common factors other than 1. Therefore, 57 and 85 are co-prime. Next one, 121 and 1331. To determine if two numbers are co-prime, we need to find their prime factorizations. Prime factorization of 121 is equal to 11 into 11. Then, prime factorization of 1331 is equal to 11 into 11 into 11. As we can see, both numbers share a common prime factor which is 11. Therefore, 121 and 1331 are not co-prime. Next one, 343 and 216. To determine if 343 and 216 are co-prime, we need to find their prime factorizations. Prime factorization of 343. How to find? 343 divided by 7 is 49. 49 divided by 7 is 7. 7 divided by 7 is equal to 1. So the prime factorization of 343 is 7 into 7 into 7 or 7 cube. See, 7 into 7 into 7. Then prime factorization of 216. 216 divided by 2 is 108. Again, 108 divided by 2 is 54. Then 54 divided by 2 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. See, so the prime factorization of 216 is 2 into 2 into 2 into 3 into 3 into 3. That is 2 cube into 3 cube. As we can see, 343 and 216 have no common prime factors other than 1. Therefore, 343 and 216 are co-prime. Is the first number divisible by the second? Use prime factorization. First one, 225 and 27. Let us find the prime factorization of both numbers. Prime factorization of 225. How to find? 225 divided by 3, 75. 75 divided by 3 is 25. Again, 25 divided by 5 is 5. 5 divided by 5 is 1. So, the prime factorization of 225 is 3 into 3 into 5 into 5. The next, prime factorization of 27. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So, prime factorization of 27 is 3 into 3 into 3. To determine if 225 is divisible by 27, we need to check if the prime factorization of 27 are also present in the prime factorization of 225. In this case, the prime factorization of 27 is 3 into 3 into 3. The prime factorization of 225 contains 3 into 3, which is not sufficient. Therefore, 225 is not divisible by 27. Next one is 96 and 24. Prime factorization of 96. How to find? 96 by 2 is 48. 48 by 2 is 24. 24 by 2 is 12. 12 by 2 is 6. 6 by 2 is 3. 3 by 3 is 1. So the prime factorization of 96 is 2 into 2 into 2 into 2 into 2 into 3. Prime factorization of 24. 24 by 2 is 12. 12 by 2 is 6. 6 by 2 is 3. 3 by 3 is 1. So the prime factorization of 24 is 2 into 2 into 2 into 3. We can see that the prime factorization of 24 is also present in the prime factorization of 96. See, 2 into 2 into 2 into 3 is also present in 2 into 2 into 2 into 3, prime factorization of 96. This means that 96 is divisible by 24. Next one, 343 and 17. To determine if 343 is divisible by 17, we can use prime factorization. First, let us find the prime factorization of 343. 343 divided by 7 is 49. 49 by 7 is 7. 7 by 7 is 1. So, the prime factorization of 343 is 7 into 7 into 7. Now, 17 is a prime number itself. Since 17 is not a factor of 343, as 17 does not appear in the prime factorization of 343, 343 is not divisible by 17. Next one, 999 and 99. Let us find the prime factorization of both numbers. Prime factorization of 999. 999 divided by 3 is 333. Then 333 by 3 is 111. 111 divided by 3 is 37. 37 divided by 37 is 1. So the prime factorization of 999 is 3 into 3 into 3 into 37. Next, prime factorization of 99. 99 divided by 3 is 33. 33 divided by 3 is 11. 11 divided by 11 is 1. So the prime factorization of 99 is 3 into 3 into 11. Comparing the prime factors of 999 and 99, we can see that 999 is not divisible by 99 because it does not have a factor of 11. The first number has prime factorization 2 into 3 into 7. And the second number has prime factorization 3 into 7 into 11. Are they co-prime? Does one of them divide the other? The first number has prime factors 2, 3 and 7. The second number has prime factors 3, 7 and 11. They are not co-prime. Both numbers share the prime factors 3 and 7. See, both numbers share the prime factors 3 and 7, so they are not co-prime. Does one of them divide the other? No, neither number divides other. The first number has the additional prime factor 2, while the second number has the additional prime factor 11. Since they don't share all the same prime factors, neither is a multiple of the other. Guna says, any two prime numbers are co-prime? Is he right? Yes, the statement is correct. Any two prime numbers are co-prime. This is because prime numbers by definition have only two distinct positive divisors, 1 and the number itself. Therefore, the only common divisor of any two prime numbers is 1. This makes them co-prime. For example, consider the prime numbers 7 and 11. Their only divisors are, for 7, the only factors are 1 and 7. 11, 1 and 11. The only common divisor is 1. Hence, they are co-prime. Children, thanks for watching. If you like this video, please like, share and subscribe. We will see you in the next video. The playlist of all the subjects are given in the description box. Please go through it. Thank you.